Let's see.
Oh, you have video out from this? No. Okay.
What's that sound?
Motor spinning.
What motor?
But be careful, Tommy. I will be very upset if you trip on a cord that knocks my projector off the table.
Or the wheel.
Get the feel. Hurting, spanking.
First cool thing to look at is the current.
And the current is right now for this one.
So pretty much as it is, that motor is close to 800 milliamps.
And how big of a chunk of time are we looking at right now?
This is 100 milliseconds per division, so that's a second.
A second, okay. So that's,
Let me take it down. So what you see here, that is basically the noise caused by the commutation. This is a brush motor, so when the commutator jumps to the next, you're literally breaking an inductor. So that's why there is always arcing on these motors. Now, notice that if I increase the load, I'm not going to use my finger for that.
you could have somebody from the audience.
Oh, yeah.
Current
Not used here. Just a demonstration that current is directly proportional to load. I am doing nothing with the voltage, right? Is the current going up?
Yep.
Yep.
1.8.
So I'm still in the same universe. The same laws applies to this. And how much the current is going to go up, that's basically defined by the torque curve of the motor. So each motor behaves differently. It has to do with how many how many turns, what kind of wire was used. Let me see if I can look at.
Yeah, or his driver will be limited, how much current.
Yeah. We had some guy at work demo some of these by Ashland.
This is a scooter motor.
So awesome.
Beautiful.
Huge screens.
Yeah, scooter motors
MSOs,
are very nice,
so they were like
and
32
people are
channels.
just getting rid of them for like $10. Sometimes I get them for free. I think you like free.
Yeah.
Now, where are you going to get these?
Just put it on Craigslist and somebody will say, I have two scooters here, pick them up.
Okay.
Sometimes I have to pay like $20. Lately, this was like last year. Lately, I have been looking on the Craigslist, and some people are asking like for $100 for a used
Yeah.
scooter with no batteries. I'm like, crazy. It's like new. Boy, we have like a little piece of wire that I forgot. I don't have many.
The alligator clip?
There's alligator
Just
clips
grab
over
one off my robot here.
What type of scooter does that come off of, like a little,
Yeah, these are the little scooters.
that you stand up on?
These are not the scooters with the rubber wire that you actually fill up with air, because those have a chain and sprocket, and those
Yeah.
are harder to. And the problem is when you remove the sprocket, basically the wheel moves only one direction with the sprocket. It is free wheel on the opposite direction, so you won't be able to move the directions. It's a different. I guess I'm going to use a different
Most
motor.
of the smaller scooters.
I'm going to use a different motor. Oh, the other thing I wanted to show you. So, if I start the motor and I stop it, it takes some time, right? Now I'm going to go into slow decay. That was fast decay. In slow decay, it should stop very fast.
Oh yeah, you can hear it.
Yeah, you see it.
What is that program that you're using for controlling the
Oh, this is a program I wrote on Visual Basic.
of your?
Visual Basic.
Oh,
I just wrote it on Visual Basic.
Homebird.
Windows 3.
So I have an MS Super 3 and I'm using an FTD chip, FTDI chip to do serial, and I'm just using the serial COM port. But I work with LabVIEW, C++ Builder, anything that codes. So that's the difference between fast and slow decay. Now on this chip that I'm using, and basically that's this tiny dinky little thing here, I don't use that to drive my R32, by the way, it would be impossible. This is a 2.5 amps device, so I think I need like 10 amps to drive R32. But I just plug it in as it is, and everything is taken care of by the chip. I don't have to worry about slow or fast decay. There's just one pin that selects that. Enable is one pin, direction is one pin, so I can change the direction. If on the other chip, well, the chip on this board, I have two half H bridges, which basically make one H bridge. So I added one microcontroller to take care of that because I don't like having to control the high side and the low side to do this kind of thing. I just want somebody. I just like the enable line. One enable line takes care of everything.
Yeah.
So let's see. This guy here.
The round.
That's my PWM signal.
These are stepper motors here?
Which one?
The one you were doing now,
Oh,
that's stepper
this
motors?
one?
Yeah.
No, that's a DC motor.
DC.
That's actually the same as this.
Okay.
Oh, okay, now, got it.
Okay. This is my PWM signal. It is running, I believe, at 32 kilohertz. Yes, 31.25 kilohertz. If I change that, notice the time on, which is basically when it is on. If I decrease the time on, the motor moves slow. If I increase the time on, the motor moves faster. In essence, what I'm doing is the same as changing the voltage of the motor. So in essence, I am doing the same as this, just changing the voltage
By changing the duty cycle.
by changing the duty cycle. So instead of having to hire somebody to get on your robot and change parts, which is very expensive, you can do it with a microcontroller.
Typical having and messing around moving motors. Tommy.
Let's see if I can show something here.
He has a blue motor hooked up. Why does he has the blue motor hooked up?
So on this driver, I'm using a microcontroller to measure the current flowing through the winding, and then enable and disable the motor as to limit current. And that is what you see here. This is the chopping.
So that's happening within, let's say, that 32,000th of a second. It's now chopping many, many, many
Yes.
times. So that's happening at a really high frequency.
Let's see. How does it fight?